Welcome, everybody, and thank you for joining us for Chemical Compatibility and BlazeMaster CPVC webinar. I'm Lainey Liotta, the Senior Fire Protection Market Manager for Lubrizol, based out of Cleveland, Ohio, and I am happy to have Michelle Knight here with me, and she is the Principal Scientist for Lubrizol and who I consider the compatibility guru, CPVC compatibility guru. So super excited to have her on, regardless of how many times you get to talk to Michelle or be fortunate enough to attend one of her presentations. I know you always learn something new. A couple of reminders. If you have questions, please put them into the Q&A section, not the chat. That way we'll be able to make sure that we answer them. And if we don't get to answer them, we'll be able to follow up with you directly to answer your questions or get you some support. Secondly, this is attending this presentation or this webinar for the full amount of time, you will qualify you to get 1.5 NICET credits. As long as Zoom tracks how long your computer is on this webinar. So as long as you're on for the entire time and you don't leave early or join very late, you'll automatically receive an email with a NICET credit certificate for 1.5 credits. Once the presentation is over, probably next week on Monday or Tuesday, you will receive that via email. If you're in a conference room and you have multiple people watching on one screen and you need NICET credits for those people, please email BlazeMaster@lubrizol.com. And we can work that out if you have multiple people viewing from one screen. So I think we went over, I don't remember if I mentioned, but this is being recorded by us, and we will be posting the recording on YouTube next week. So there's no need to record on your local device or anything like that. It will be free for public viewing on YouTube afterwards. However, if you do watch the video on YouTube, that will not qualify you for NICET. So we'll go ahead and get started. To encourage you to stay, move on to the next slide, please. To encourage you to stay for the whole time and to pay attention the whole time, I wanted to point out just a few things that we're going to talk about that are probably different from the compatibility webinars you may have been on before. We have Michelle Knight here, which she's phenomenal. And she's going to explain everything you need to know about chemical compatibility with Lubrizol CPVC products. But we're also going to go into like very hot topics in the industry. And one of those is, can you use polyurethane spray foam with BlazeMaster CPVC? Common misconception is that it is incompatible. That's not true, and Michelle will tell you why. Another big misconception is that UV light exposure really is detrimental to CPVC, and that is not true either. And then there's I keep hearing rumors that Lubrizol profits off of our FPC system compatible program. That's not true either. So we are going to go through all of that and so much more. So make sure that you pay attention. To the next slide, please. So before we get started, I'll just tell you a little bit about Lubrizol Advanced Materials. Lubrizol is part of Berkshire Hathaway, so we're a Berkshire Hathaway company. And we are a specialty performance chemical company, and we have a division that is dedicated to CPVC. So we not only make the resin and compound for BlazeMaster CPVC, we also make the resin and compound for FlowGuard Gold, which is used in plumbing products, and Forzan, which is used in industrial and commercial plumbing. We also have a UL listed FreezeMaster, I'm sure that many of you are familiar with, that we developed as well. As I mentioned on the last slide, Lubrizol manufactures the compound, right? So the powder and the pellets that go into the pipe and the fittings. We do not manufacture the fittings and the pipe themselves. We have we have manufacturing partners that actually make the pipe and the fittings themselves. And those in North America are Johnson Controls and Viking, play in the United States and Canada. And then in Canada and Latin America, we have IPEX, and then GF Carvel sells pipe only into their ASD systems. But we're very, very proud of our partners and the quality and the expertise that they bring to market. So when you are using a Lubrizol product or BlazeMaster CPVC, you not only get the backing of the scientists of the company that invented CPVC, you get the backing of the leading industry, fire protection industry experts in Johnson Controls and Viking. So in all, today, we're going to understand from Michelle the science of chemical compatibility at a high level. If I can understand it, I know that you can understand it. And Michelle does a really great job at sort of dumbing down, so to speak, a very complex topic. And then I think more importantly, we're going to understand how we apply that science and that understanding of compatibility onto the job site, because science doesn't always equal the practicalities or the real world situations that we face in the field. So we're going to talk about both today. And with that, I will turn it over to Michelle, and I will go off mute so that you don't have to hear my airport background.
Well, good afternoon, everybody. I'm happy to be here talking to you about chemical compatibility. Scott, if you can move on to the next screen. First of all, I just want to talk about the words compatible and incompatible, because there's sort of a misperception out there that compatible is something like alive or dead. You're either alive or you're dead. You're nothing in between. When in reality, compatibility is more like temperature on a scale. You can go from very hot to very cold and all sorts of temperatures in between. So chemicals vary in the amount of effect that they have. Some of them are very aggressive towards CPVC and can cause cracking or softening in almost any situation. Some of them have a mild effect, and so they may need other factors to cause the pipe or fitting to fail if they come into contact with the pipe or fitting. So the question for compatibility is really how hot is too hot, and what are those other factors that may be contributing to compatibility issues. And so we're going to talk about all of that in the presentation today. So just a little bit of background about compatibility. Not many materials are impervious to everything around them. I've got a picture of some gold and diamonds down there on the bottom right, and that's because that's about the only thing that is really quite impervious. And if you want something that is not going to be affected by anything around it, you're probably going to have to pay about what gold and diamonds would cost. So any material that you use is going to be sensitive to something. Metals can be sensitive to just the oxygen in the atmosphere. Water can cause corrosion of a lot of metals, or the quality of the water, if it's high in sulfur or high in or low in pH, that can be corrosive. Microbial growth, especially in a stagnant system like a fire sprinkler system. A lot of microbes, when they metabolize whatever it is they're eating, they excrete acids, and that can cause corrosion of metals. And everybody's familiar, of course, with galvanic corrosion, where you just have two different types of metals in contact with each other. Some types of plastics can also be sensitive to oxygen in the air, UV light, exposure, water quality. And so you just need to be aware of the material that you're working with and what it might be sensitive to. So today we're going to focus specifically on CPVC. And if Scott can move to the next one. So focusing on CPVC, what is it exactly? So our starting raw material is PVC, the same sort of PVC that you might use in industrial or commercial water piping. And we take that and we add extra chlorine to it. So PVC is already 57% by weight chlorine. It's polyvinyl chloride. And we add more chlorine to it using UV and heat as catalysts, and that makes CPVC. So by number, we're adding about 50% more chlorine atoms to the PVC, and that gives it higher temperature performance, better flame and smoke performance, better chemical resistance to acids and corrosives, and so forth. So that's just the CPVC resin itself, but CPVC is a compounded product, so we take that and we add additives to it. We add things like heat stabilizers, UV stabilizers, pigments, processing aids, impact modifiers, and so forth, to make a final compound. And we sell that compound in powder and pellet form. So you see some powder and some pellets there on the right. That is the product that Lubrizol makes. Pellets go into fittings, powder goes into pipe. And they're not exactly the same compounds. You use different resins and different additive packages for pipe and fittings just because of the different challenges in extruding pipe versus injection molding fittings. You just need to formulate the material a little bit differently in order to process it in those different ways. So we sell the powder and the pellets to the people that Lainey mentioned earlier. And they will process it into pipe and fittings to make the BlazeMaster products that you buy. So this red and gray blob is actually a schematic of a CPVC molecule, or a little segment of a CPVC molecule, and the big red blobs are the chlorine atoms. And as you can see, there are a lot of them. They are huge, and they protect the gray string of atoms in the center of the molecule. And I like to talk about CPVC as kind of being a little armadillo of a molecule. Those big chlorine atoms are huge. They are kind of like armor plating on the backbone of the molecule, and they prevent acids, corrosives, oxidizers from getting in and breaking the back of the molecule and breaking it down into little bits, which would be how it would degrade. One question that we frequently get is, about UV light. We make CPVC, as I mentioned on the previous slide. We use intense UV light to actually make the CPVC. And when we use that intense UV light, we're making free radicals, which are very aggressive chemicals. And we're doing that in the presence of high concentrations of chlorine gas, which is a highly oxidative chemical. So when I call it a little armadillo of a molecule, that's because it is. It is really, really resistant to these sorts of things that can break down other plastics and other types of materials, UV light, hot, strong oxidizers like chlorine and free radicals. CPVC is really quite impervious to those to a high degree. And so in industrial applications, we're used for handling battery acid, caustic soda, hydrogen peroxide at high concentrations. And all of these very corrosive chemicals really have little to no effect on the CPVC. And one other thing to mention about our industrial products is they're frequently installed outdoors in pipe racks in chemical plants for decades, and they maintain their pressure bearing capability just fine. So moving on to the next slide. So when we get questions about UV light, we can very confidently say there are no incompatibility problems. There's no degradation problems with UV light and BlazeMaster. It doesn't affect the long-term pressure bearing capability. We've tested aged pipes that have been out in the sun for years, and they still maintain their pressure bearing capability after a very long time. So we don't see any degradation, any molecular breakdown of the CPVC. The UV light will kind of fade the orange pigment a little bit, so you might see some discoloration. And it does age the pipe and fittings a little bit faster. So every material ages, everything gets a little tougher and harder to work with. The older it gets, and UV can accelerate that a little bit. So you may experience some difficulty cutting the pipe without cracking it if you install some pipe that's been lying out in the sun for a while. But if you can get it installed without cracking it as you're cutting it, it will maintain its pressure bearing capability and perform just fine. So the next slide. The next slide talks about what holds polymers together, because when we talk about compatibility and chemical compatibility failures, we're going to be talking about what pulls molecules apart. So I'm just very briefly going to talk about 3 different kinds of polymers that you're probably familiar with, even though you might not know they fall into these categories. So polymers can be held together by 3 different things. One is just molecular entanglement. Plastics are all very, very long chains molecules. And in some cases, we're just tangling those chains up together. And that makes a solid piece of plastic. The good thing about this kind of plastic is that you can solvent cement it. You can dissolve it with solvents and use cements to put it together. And you can weld it, heat weld it, which is often done in industrial applications. But it's not as easy to weld, say, as something like polyethylene, which you see in the center there. This is a crystalline material. It melts. CPVC, you may have seen a video of CPVC with a flame applied to it. It doesn't really melt, it just kind of chars in place. Whereas polyethylene, polypropylene, those kinds of things, when you put a flame to them, they can tend to run like candle wax because they melt and become liquid, literally, when heat is applied to them. Makes them easy to weld, but not very easy to join with solvents. But it also does give them some improved resistance to cracking, because those crystals hold together in the presence of solvents and other types of chemicals. And then the third type of polymer you might be familiar with is a cross-linked polymer. Fiberglass is typically a cross-linked polymer, or if you're familiar with PEX plumbing, that's also cross-linked. So these can't really be dissolved in solvents. They're hard to weld. They're typically joined mechanically. Moving to the next slide. So in order to cause environmental stress cracking, which is the most common form of chemically driven failure in CPVC, is chemically driven cracking. As I mentioned earlier, you may need just more than just the presence of the chemical. Other factors may be contributing to the failure. And I like to describe it as a fire triangle, because we're all in the fire safety industry here. We're all familiar with this. You need 3 factors to cause a fire to burn. You need the right amount of fuel, the right amount of heat, and the right amount of oxygen in order to get a flame to propagate. And if you have too much or too little of one or the other, then you may not get a fire at all. We're all familiar with this. It's very similar with chemical compatibility and chemically driven failures of plastic. Besides just the presence of the chemical, we also have mechanical stresses on the part that may be contributing, and the quality or strength of the material itself. And so we're going to talk now about all these 3 factors. We'll start with material and part quality. We'll talk a little bit about stress, and then we'll move on to the chemicals after that. So material and properties. Here's a couple of pictures we've already seen before. We've got this picture of the molecule of CPVC. You can imagine, with all those big chunky chlorine atoms on it, it is hard to get that molecule moving. We have to apply a lot of heat when we're processing the CPVC. It's about 425 degrees Fahrenheit to get those molecules moving. So we take that, we make powder and pellets out of it, like I mentioned before. And those powder and pellets then have to be processed into pipe and fittings at about, like I said, 425 degrees. And the whole purpose of the processing is not just to shape it into a pipe or to shape it into a fitting. We've got to get all those molecules tangled up together in order to achieve the ultimate strength of the part. So you can quite easily visualize all those individual grains of powder aren't tangled together at all, and the molecules inside them aren't tangled together either. And so besides just shaping the material into the part process, we need to get all those molecules tangled up, and it's not necessarily as easy as it seems. So this just speaks to the importance of choosing a quality manufacturer when you're choosing to buy pipe and fittings made out of CPVC. So the next slide, we'll talk about mechanical stresses, and these can come from a lot of different kinds of sources. On the bottom left there, we just see a lot of different ways you can apply stress to a material. So you can stretch it, that's tension. You can squeeze it, compression. You can kind of bend it or twist it, or shear it, which is kind of like pressing and bending at the same time. And so those are the different types of stress. One of the most easily thought about types of stresses is the pressure inside the pipe. So we've got that little pressure gauge there. There's going to be pressure inside the pipe as it's holding the water in. That's one source of stress. One source of stress you may not have thought about is the actual tapered joint itself. Unless you're brand new to using CPVC pipe and fittings, you probably know that the socket of the fittings are tapered and slightly smaller at the bottom than the size of the pipe. That makes a really tight joint when you make those solvent cement joints properly. If you've seen a burst test of a solvent cemented assembly, you'll know that it doesn't fail in the joint, it'll fail in the pipe. It makes a really strong, tight joint, but it does apply some stress to the fittings. And so when you have chemicals applied to the outside of a pipe or fitting system, as we'll see a little bit later, that stress in the fitting may be a contributing factor to the failure. Other types of stresses may be just how the pipe is installed. Of course, it's got to support its own weight between the hangers, but as you can see on the top right there, there's an awful lot of other things that can apply stresses to pipe and fittings. In some cases, you've got, for instance, cable conduit weighing down on the pipe. You may have the pipe pressing into beams or struts or something in the building. You may need to bend the pipe a little bit to get around a small obstruction. So all of these different types of things can also contribute some amount of stress to the pipe or fitting. And so in the presence of a chemical that can cause environmental stress cracking, these may contribute to causing a crack to start. And so next we'll talk about the different types of chemicals and where you might encounter them on a construction site. So you can, again, categorize the chemicals in three different categories. There's lots of different chemicals, but they can all kind of be categorized in these three big categories. First is plasticizers, and these are used to make things flexible and rubbery. So flexible, soft, rubbery materials you might come in contact with on a construction site, they may contain incompatible plasticizers. And we've got some individual slides coming up after this that will discuss all these three categories in more detail. The second category is natural or synthetic lubricating oils. And I've been in this industry a long time, over 30 years, and There's a bit of folklore in the industry that petroleum oil is particularly bad for CPVC, and that's exactly what that is folklore. It has a small effect, but the oils that are really more of a problem are the natural oils, so anything animal or vegetable based, those sorts of oils and fats, or synthetic lubricating oils. But petroleum is really fairly minor in its effect on CPVC. And then the third category is surfactants, which is just a chemist's term for something like a soap. So not every kind of soap is incompatible, but certain types of modern synthetic detergents are incompatible. And these are kind of ordered. You can see I've got my little thermometer up there reminding you that chemicals can vary in the amount of effect that they have. And these are kind of ordered in rank by the worst to the best. So plasticizers are very aggressive. They're used to make hard plastics soft and flexible. And when you have a hard piece of pipe, you don't want it to become soft and flexible. It's not going to hold pressure very well. So those are very aggressive. And then the synthetic oils are kind of in the middle of their effect. They require some amount of stress in order to get the cracks going. And then surfactants are even less aggressive, but they can cause cracking of the CPVC in certain instances. So coming up next, we'll be talking about where you might find these types of chemicals in a job site. So as I said, plasticizers, they're used to make hard plastic soft and flexible. One place you might come into contact with these is with wire and cable, and specifically a communications type cable, as you see on the top right there. The typical Romex wire that is used to carry electricity to the outlets and the light fixtures is usually compatible with CPVC. You shouldn't need to worry about that. It's usually got a nylon or a polyolefin jacketing on the outside. But communications type cable, so anything like cable TV wires or computer systems, those sorts of things that are carrying signals instead of electricity, those may have incompatible plasticizers in their jacketing. And if you think about handling those on a job site when you're doing, or maybe doing construction around your own house, you can tell the difference in feel between Romex and say a coax cable for a cable TV system. And that's the kind of difference you're looking for. That slick Romex feel is probably okay. That sort of a little bit tackier coaxial cable type feel is maybe questionable. Some other places you might find incompatible plasticizers in a construction environment is in caulks and fire stops. This is going to be both general purpose caulks and fire stopping materials. And of course, we're going to talk, Lainey's going to talk to you later about the system compatible program where you can choose compatible fire stopping materials. There's a whole lot of them available on the program. So we encourage you to use those and not just pick something off the shelf, because an off the shelf material that's not on the system compatible program may contain incompatible plasticizers. For general purpose type sealants, as opposed to fire stop sealants, so just something to keep the air from coming through a gap in the wall or something, those generally silicone will be suitable for use with CPVC. But other types of materials may contain incompatible plasticizers. Squishy tube insulation. So you see a picture there in the middle of some of that black tubing insulation pressing up against a piece of BlazeMaster and causing a leak in it. Not all types of tubing insulation are incompatible, but if you think about the types that you may have seen at Home Depot or wherever, there's one that feels crisp like a pool noodle, and that one will be okay for contact with CPVC. Those are not incompatible. But then there's some other types of insulation that feel more squishy. And those are more questionable. You want to avoid those and choose the pool noodle ones if you're going to have tubing insulation up against the CPVC. Either whether you're going to insulate the CPVC itself, or as in the case of this photo you see here, that some other type of material that's insulated but pressing up against the CPVC. Other places you might find incompatible plasticizers is in electrical tape. Any other kind of tape is fine. Duct tape, masking tape, scotch tape, strapping tape, paper tape, those are all fine. But electrical tape, or anything that feels like electrical tape, and you know what electrical tape feels like, it's stretchy, and it's got that same feel as a coax cable, actually, because it's about the same material. So anything that looks and feels like electrical tape, you should avoid using on CPVC. Some types of weld penetrants will have plasticizers in them, and if you're testing welds on the steel pipe somewhere and getting the weld penetrants inside the steel pipe, that can eventually wash down into the CPVC and cause problems. So it's best to try to avoid getting those inside the steel pipe if you're using them. Fragrances are incompatible with CPVC. Some people like to do air pressure tests and put something fragrant inside the pipe in order to detect the air leaks, but that is not a good idea with CPVC. The fragrances will cause the CPVC to crack. And then that little bit of advice down there at the bottom is just if you're asking a supplier of some sort of material if it's compatible, these are examples of things that should not be in there. And yeah, they're long chemical words, but rubber material suppliers should know what they mean. And speaking of rubber materials, some rubber that might be used in hangers or those sorts of things can also be incompatible with CPVC. And so those are the kinds of plasticizers inside the rubber that you need to avoid. So the next category is the natural or vegetable types of oils and synthetic lubricants. These can be found in kitchen grease. So we've got a picture of a kitchen over there. If the piping is installed exposed or in a place where kitchen grease can settle down on it, and if you've ever cleaned your own kitchen, you know that grease gets everywhere and settles on top of everything. So if the grease is able to settle on top of the CPVC, that can cause the fittings to crack, again, because of the stress in a typical tapered socket joint. But you can just very easily avoid that problem. If it does need to be installed exposed, you can very easily avoid that problem by either painting the pipe, if that's allowed by the jurisdiction, or by applying one of those crisp like a pool noodle sorts of insulations that will keep the grease from landing on the CPVC. If you're using cutting fluids, as I said, petroleum is a bit of folklore. We would prefer a petroleum-based cutting fluid as to anything that is marketed as green or plant-based or renewable. Those are usually vegetable oil-based lubricants and more likely to be incompatible with CPVC. And some thread sealants also will contain incompatible oils like linseed oil or castor oil. And again, here's another great opportunity to use the system compatible program, because there are a lot of compatible sealants listed there that you can use and be confident you're not going to have the problem that you see in the picture there, which is a cracked sprinkler head adapter that had an incompatible thread sealant used on it. And then the third category of chemicals, Scott. moving on. There is synthetic detergents. So these will again tend to crack the fittings, and that's a plumbing fitting on the top right there, but it's the best picture I have to show the problem. These will again crack the fittings typically if they're on the outside of the system because of that stress from the tapered socket. That is a fairly high amount of stress. And so you might find these in some types of leak detectors. So the soap blowing bubbles types of leak detectors, those obviously have some type of soap in them. There are some compatible products available on the system compatible program again. Some types of cleaning products, disinfectants, mold and mildew killing chemicals. Some of these may also contain incompatible chemicals. And again, you're going to want to check the system compatible program because some of these types of chemicals can also be found, compatible versions can also be found on the system compatible program. So yeah, so other types of incompatible things or might be, again, we mentioned cologne and perfume earlier, termiticides, insecticides, fungicides. Some of these contain solvents, some of them contain these similar types of incompatible detergents in order to disperse the insecticide in the water, for instance. And then some special topics are on the next few slides, one of which is polyurethane foam. So there is, as Lainey mentioned earlier, some discussion in the industry about polyurethane foam. And when polyurethane foam is being installed, what you want to see is what you see over there on the left, which is a nice, even, not too thick coat of foam that all foams up very nicely and covers everything completely. Because, as you may be aware, polyurethane foam is a two-part product when it's applied like this. So there's a part A and there's a part B. And CPVC is actually not compatible with either part A or part B. But once they have reacted and foamed up, and if you've ever watched this stuff applied, you know that it reacts and foams up pretty darn quickly. So as soon as that process is complete, the final product is compatible with CPVC. And why is that? Well, the monomers that form the hard plastic part of the foam, they react together and form a hard plastic. And so that can't have any effect on the CPVC. And then all the additives that were in part A and part B are kind of lifted up in the foam. And I've got a picture of the foam there in the middle of the top right. And all the additives are going to be in the plastic that makes up the bubbles. And they've got a hard path to get back down to the CPVC. They can't migrate through the air in the bubbles. They have to migrate through the path of the walls of the bubbles, and effectively they just never do. They don't have enough time in the lifetime of the building to get back to the CPVC. So the structure of the foam is what actually makes it not harmful to the CPVC. But in cases where the material does not foam up, so on the top right there, you see some sort of unfoamed or just barely foamed material sitting on the surface of the CPVC. And in the center on the bottom there, it's just literally some crystallized, there wasn't any, I think, part B on that material that just landed on the CPVC and stuck there. And you can see the crack that it caused in the bottom center. So when this happens, when it's not properly applied and you have an excess of A or an excess of B left on the surface of the plastic, that can cause some cracking. And then one other issue to mention with polyurethane foam that doesn't really have to do with compatibility, but it's worth talking about while we're here, is just the heat. When polyurethane foam cures, it can get up to 300 or more degrees inside the foam. And that picture on the bottom right there, it's CPVC plumbing pipe. The same thing can happen to BlazeMaster, but the best picture I have, again, was a plumbing pipe. That the water actually boiled inside the pipe due to the 300 or 350 degrees from the foam curing on the outside of the pipe. So when there's going to be polyurethane foam installed, there's a couple of things you need to think about. One is they need to put it on in thin layers so that that heat can dissipate. And that's the picture on the left there. You see it's you know, an inch maybe of foam. A couple inches of foam is okay, but you know, if you're going to fill a 6-inch joist space, you really need to do 3 passes. You can't do it all at once, or it's going to get really super hot in there, and that may boil the water inside the pipe. Another thing you may need to think about is thermal expansion of the CPVC. If it's going to be installed in polyurethane foam, you might want to think about putting some expansion loops in order to compensate for that, just in case there's any significant expansion due to the heat in the foam. And the next slide talks about a common question we get, which is paint. CPVC can be painted with paint. We recommend water-based latex or acrylic latex paint, but really any kind of paint except 2-part epoxy is pretty well compatible. So spray paint or an alkyd or oil-based paint or latex paint, all of these kinds of paints, as long as they're applied, you know, in a normal application, a thin coat that's able to dry easily. You don't want to just pour paint on everything and have big thick puddles of paint, just like you don't want big thick puddles of solvent cement, but normal painting will be fine. And even 2-part epoxy, as again, it's kind of like polyurethane foam. CPVC is not compatible with either part A or part B of an epoxy, but again, as long as it's a thin coat that cures quickly and you don't have an excess of one or the other, even epoxy will be okay with CPVC, but it's going to be easier and less complicated if you choose a 1-part alkyd, spray paint, water-based latex, acrylic. Any of these kinds of common house paints will be fine. One thing you do need to be aware of, though, is that the authority having jurisdiction may not be happy with you painting over the markings on the pipe. So you need to have some okay from that person before you go ahead and paint over the listing marks and so forth on the CPVC. And if you need any kind of a letter about that, you can contact blazemaster.com. And I like to end with things you don't usually need to worry about. So these are a lot of common questions that we get. I've got a picture of paint right there on the left. We just talked about that. Other types of things you don't need to be worried about. Most other forms of insulation, so like the blown-in cellulose or the fiberglass, whether it's blown in or batt, those types of insulations, they're all fine for contact with CPVC. Spackling and drywall mud, that's not going to be a problem. This kind of mylar ducting insulation that you frequently find in building insulation, that's not a problem. We get a lot of questions about sprayed on fireproofing for steel. That is also not a problem for CPVC if it gets sprayed on it. If you need to use Sharpie markers on the pipe, go right ahead. Those are not a problem. And again, as I mentioned earlier, most types of tape, including duct tape, Scotch tape, masking tape, blue painter's tape, strapping tape, paper tape, any kind of tape, except what did I talk about earlier? Electrical tape. Don't use electrical tape, but any other kind of tape will be fine. And I think from here, Lainey is going to tell you where you can find all this useful information on the System Compatible program.
Absolutely. Thank you so much, Michelle. And we have a ton of questions that we'll definitely get to at the end, those that relate to compatibility for sure. So Michelle will join us back on at the end. Again, for those of you who were not on at the beginning, I am at an airport and I apologize for the background noise. But now that Michelle went over all of the science and things to watch out for, and you have a better understanding of what kinds of chemicals can adversely affect BlazeMaster and why, let's go over what we do with that information and how you can ensure compatibility on a job site. We have something called the FBC System Compatible program, and it really takes the guesswork out of chemical compatibility with Lubrizol CPVC products such as BlazeMaster. FBC stands for our brands of CPVC, FlowGuard, BlazeMaster, and Corzan. So that's where that comes from. Lubrizol, or a Lubrizol company, invented CPVC, and we invented the compatibility programs to go along with it. We identified a need for that, and identified, developed testing protocols, et cetera, as well as the FBC program that is very easy to use and straightforward to for all trades to use in the industry. Michelle will explain a bit more about this later, but while we absolutely have the testing capabilities ourselves to test for compatibility and have developed those protocols, et cetera, just to add credibility to it, we have a third party actually administer the program and do the testings as well, to make sure everything is neutral and repetitive and done correctly. The materials and the brands that are part of our program, we require them to test annually so that we can ensure that no incompatible materials have been maybe added to the ingredient list or something like that. And they also agree to notify us anytime they make a change to the formulation of the product, just to ensure that there's no issues. And so anything that is on the compatibility program and listed with as FBC System Compatible, it's compatible. And one common misconception is that our program applies to all brands of CPVC. That is not true. Chemical compatibility, there's a lot of factors that go into it, as Michelle explained. One of those being, the actual material properties. The material properties for Lubrizol CPVC are unique, and we cannot speak to whether or not a material is compatible with a different competitive CPVC product. So in the fire protection industry, our program only applies to our brand, not competitive brands. And then lastly, we have, Michelle being the compatibility guru, as I call her, as well as 20 plus field team members that are there to assist with any sorts of questions that you have regarding compatibility, give trainings, etc. One thing that a lot of people aren't aware of, and we get a lot of emails, and really we just to respond to the emails, we copy and paste verbiage directly from our website. It's fbcsystemcompatible.com, or if you can't remember that, it's blazemaster.com, and then click on compatibility. That leads you to the FBC System Compatible website, in which, if you go to the next slides, there's really helpful tools on that website broken out into 4 parts. And we just made a little bit, implemented some changes on the website to make it more user-friendly and straightforward and more intuitive. So I'm very happy about that. But the first thing that I think is very helpful on the website is called the Compatible Product Finder tool. And I'll give a demo of that here in just a second. But that's basically the list of the products on our compatibility program, those products that submit to be tested annually, and sign a contract basically informing us that they're not going to change the materials within their formulations without notifying us. The second tool we have on there is a list of products that we found to be incompatible with BlazeMaster or Lubrizol brand CPC. And that's either materials that we've identified in the field or materials where someone sent us a SDS or something like that, and we say, oh, there's definitely appears to be incompatible materials there. And so obviously we can't have every single product in the world on either of those lists, but we try and add anytime we find out of a brand or product that is definitely could cause some concern, we'll add it to that list. Then the third, which is very seldomly used, and I think most of that has to do with it was kind of difficult to find, or it wasn't intuitive to find on our website. It's the other chemical compatibility topic. And this page I use all of the time, and I think is probably the single most important topic or the section on our website. It's other chemical compatibility topic. And it has a list of tons of product categories and guidance on things on types of chemicals to look for in the ingredients, on things that are typically okay, things that typically aren't. It's basically this PowerPoint in Word format on that website. So it's pretty self-serve. Basically, all the information that you would need to know for almost any construction product is there. And anytime you email us, we basically copy and paste the verbiage directly from that section and email it back to you. Also on the website are just a bunch of educational resources like video training, a white paper from Michelle, but just help you or your customers or the GC, etc., better understand chemical compatibility. So as mentioned, I am going to just take you through a few slides on how to utilize our compatible product finder. So you can do this either on the mobile app. To search for the mobile app, I think you have to do FBC system compatible, and that's how you'll find it. But this is just a screenshot of the online version of it, so what it looks like on the website. But the first thing you do is you just go to find FBC system compatible product. Then you select the category for the product that you're looking for. And in this example, we're looking at fire stop sealants. So you would just select fire stop sealants, and a list will show up, and you can go through and look for the product that you're using. If that product is not on that list, you go to the next step, which is to review incompatible products. And as mentioned, there's several different ways we find incompatible products, and we have listed there how we determine that product is likely not compatible with Lubrizol CPVC brand. So the categories we have within that incompatible product list are caulk, duct sealant, fire stop, leak detector, pipe clamps, pipe tape, thread sealants, and waterproofing. And if the fire caulk in this example that you're looking for is still not on that list, that's a good thing. You will move to my favorite part of the website, the review other chemical compatibility topics. And so these are all of this list on the screen here are all of the categories or product categories that we provide detailed guidance on in terms of what is compatible, what isn't compatible, if using one of these might affect the listing for BlazeMaster, etc. As you can see, there is a various product categories there, and there's an example on the next slide of the type of guidance that is provided. We have, fragrances, heat trace, and plastic pipe and flexible ducting guidance, just screenshots on here, but I just wanted to show examples of some of the verbiage and, instructions you get by going to that section of the website and just clicking the drop-down box. And I think someone in a Q&A on here asked if you could get a PDF of something for compatibility, etc. This is our version of providing a PDF. Basically, go to this website, and if you need to print it out in PDF form, you certainly can. But that is how you should be submitting the information that you have to show to the AHJ or whoever else needs it. So I'll invite Michelle to come back on here to explain how products get added to the FBC system compatible program. As I mentioned before, I think I've heard in the field specifically from our competition rumors that Lubrizol profits off of the FBC system compatible program because we do charge to be part of it, but really that charge only covers just the expense of testing through that third party. So there's no profit involved in that because that, I mean, we want compatibility issues are not good for the industry nor for us. So we would not want to monetize it in any way, but we do just have to cover the cost of testing. And I'll let Michelle explain quickly the process that a product has to go through in order to become part of the FBC system compatible program.
Okay, so the system compatible program has been out there for over 20 years, and when we started it more than 20 years ago, we already had a good 15 years of experience in the fire sprinkler industry, a good 30 years of experience in the plumbing industry, and so we based our testing criteria on that experience that we already had. We knew some types of materials were compatible, some types were incompatible, and we used that experience to be able to draw distinctions between what's good and what's bad, basically. And so for products to get added to the FBC system compatible program, first of all, it involves the manufacturer itself because they're going to have to be audited eventually. So even if you have your favorite thread sealant that you've been buying for 20 years, if it's not on the program, you can't send it in and ask us to test it for you. The manufacturer has to participate in this because they're going to have to, first of all, disclose their entire formulation to the third-party lab that does the screening and the testing. And so they're going to want confidentiality with that lab. They don't want to give their formulation to us. And then also the manufacturer needs to be involved because they're going to have to be audited every year. So the first thing they do is submit their entire formulation to the lab, and the lab screens that formulation for various types of ingredients that we already know will be a problem. So we look for those sorts of plasticizers or surfactants or oils in the different types of products they might be found in. And in some cases, we just screen them out automatically based on that formulation review. Presuming they pass the formulation review, then they have to go through testing. The testing takes more than 6 weeks to complete, and it's done at their expense. So they have to pay for it, but that is literally payment for services rendered. You have to pay the lab to screen it and to test it, and so they don't have to pay a fee to Lubrizol or anything like that to participate in the program. They just literally have to pay for the services that they receive in getting their product screened and tested. And then they have to sign a very long, complicated contract because the contracts are always long and complicated for anything, aren't they? But they have to sign a contract that basically prohibits them from changing the formulation without going back through the screening and retesting as necessary in order to maintain the compatibility of the product going forward. Then they're going to have to get audited every year by that third-party lab. They're going to go in and check to make sure they're using the listed formulation, and they're going to collect a sample of the product, and it's going to go through an abbreviated version of the same testing it went through to get on the program. It's going to go through that again every year just to make sure it's maintaining its compatibility. And again, they're going to have to pay for that service as well. And then they are allowed to or may be required to put that little FBC logo on their containers and in their literature, so that when you're out there looking for a thread sealant or a fire stop, you can tell right away that it's been tested and found to be compatible with BlazeMaster pipe and fittings. And one question that we frequently get is about some of these bigger categories of materials: the paint, the wire and cable, general purpose caulk. And the basic reason you won't find any of those on there, although as Lainey mentioned, you can find a lot of very good guidance on the other compatibility topics page. But the reason you won't see paint or wire and cable, for instance, listed on the system compatible program is just because of the sheer size of these products. Sherwin-Williams is not really going to sell one more gallon of paint just because they can claim that it's compatible with CPVC. General Cable is not going to sell one more foot of cable by being able to say that it's compatible with CPVC. They're not going to jump through all these hoops and get audited every year in order to get a logo on their product that isn't really going to bring them any more revenue. But again, if you have questions about these kinds of things, we have lots and lots of good guidance on these big category kind of products on the other compatibility topics page. So
thank you very much, Michelle.
You're welcome.
Appreciate that. So now that we know how products get onto the compatibility program and understand compatibility in general, what are some best practices? One is, like Michelle mentioned, the products that are on our compatibility program will always have that FBC system compatible logo on their packaging. An example of that is on the right hand top corner of the slide. So look for that logo. If you see that logo, you are good to go. Always verify, if you don't see that logo, you can always verify on our website or our app. And if you're still not seeing what you're looking for, you should look at our other chemical compatibility topics section, obviously. But then we definitely recommend you go directly to the manufacturer of that product, because a lot of times if you send us an MSDS or an SDS, a lot of the products are proprietary, and so they don't disclose the entire ingredient list for those products. So it's very hard for Michelle to take a look at just an SDS itself and say, yeah, this might have a problem, or no, it won't, etc. So she'll be able to look and say, in general, maybe something sticks out where it's definitely not compatible. But overall, only the manufacturer knows specifically what's in that formulation, and they're going to have to tell you whether or not it would be compatible with CPVC. Or, if the product you use a lot and you want a concrete answer, can please encourage them to be part of the BC System Compatible program. Or if it's a category for which we don't test, or for not that we don't test, but for which that's not on our program because of like a paint or something like Michelle mentioned, we have in the past signed non-disclosure agreements with those manufacturers to take a look at their formulation, to be able to say, it looks like there's chemicals that are incompatible or that are likely not incompatible with BlazeMaster. Slide. So now, just across the job site, I think all sprinkler contractors and designers are very well familiar with CPVC and compatibility. And unfortunately, where a lot of the issues come in is either other trades during installation, or once the building has been in use and maybe there's renovations being made or additions or maintenance. And so we have some tips on how to ensure compatibility throughout the lifetime of the building. And one is specifically, when you're dealing with, the construction of a job, is including language about compatibility in the specifications. You should definitely do that. It's just an added level of protection for you as a sprinkler contractor, designer, engineer. But it is certainly a best practice. We also definitely recommend you educate the general contractor, as they are the ones that are speaking with all of the trades, regardless of who they are, and they can make the trades aware of the fact that there's CPVC on the job, and compatibility has to be paid attention to. We also recommend that you post job site notices in public areas such as the restroom, elevators, etc. But that is a good way to ensure, make people read them while they're waiting to get up to the 12th floor of the building or something like that. It's a really good way to kind of get the message out and just increase awareness. Education is key to avoiding any types of concerns and issues. Just like making sure the GC is aware, it's really important to make sure that the building owner or property manager is aware, and we have tools and resources that I'll show you in order to help with that. But really, we recommend that you have or instruct the GC to have a conversation with building owner about not only the new construction of his website or of his job site, but the maintenance and upkeep and any sort of, for example, mold remediation or anything like that, that those are the types of things he really has to be conscious of. And making sure that any sort of janitorial staff, et cetera, is informed and aware of compatibility and CPVC. We recommend posting signage anywhere where the BlazeMaster pipe is exposed and could be touched by the janitorial staff, or a contractor, or in an area, like an access panel or something like that, where it's likely that if a contractor is going to be doing any work, they're going to go to the access panel first, and they'll be able to see a notice there, and maybe think twice or verify the compatibility of the product they're going to use. We also recommend that you isolate or protect the pipe from potentially incompatible products. CPVC can be installed exposed with smooth, flat, horizontal sealing. However, if you think that there's issues or potential for compatibility concerns, you can put insulate it somehow, or just create sort of a barrier between the pipe and any sort of incompatible product. And then all of those above, we have free resources from us, JCI, and Viking to help you accomplish those best practices up top. Sample specs on our website. We have the program app and website that we've reviewed. We have multiple trainings for all types of audiences, job site notices, and turnover letters. Fine. These are just examples of the job site notices that are available on our website at blazemaster.com, as well on Viking and Johnson Controls website. But it just is a shorthand version of this presentation, informing the job site or people on the job site what to look out for. And then this is the example of a turnover letter for the building owner, and something that you can also, we recommend sort of posting in those public areas or anywhere piping is exposed, like we said before, but those are also available on our website and our manufacturer's website. And now we will open up the floor for Q&A. Hopefully you found that helpful. We have about 20 minutes. We left lots of time to answer questions. If we haven't gotten to the question yet, it's because we were saving it to answer live. Those that didn't necessarily have to do with compatibility or were very straightforward, we tried to answer in the chat. If we don't get to your question by the end of the webinar, you can email blazemaster@lubrizol.com with that question, or if you didn't submit it anonymously and you used your email to register, we can email you and reach out, but we will try to get to everyone's question before the end of the call. And I think Michelle is going to be the one on the hook for answering most of these. And I, again, apologize for the background noise that you might hear coming from my end. Start with, are there, Michelle, any compatibility issues with manufactured products?
I'm sorry, I didn't hear what you said.
Manufactured wood products.
Oh, so like treated lumber and things like that, I assume. Yeah, no, there's no problems with CPVC coming into contact with treated lumber or particle board or things like that.
What is the shelf life of BlazeMaster pipe and fittings that have not been exposed to UV light or don't have any sort of contamination prior to install? Are
There
you
really,
aware?
yeah, there really isn't a shelf life. There's no expiration date on the pipe and fittings, you know, as long as you can cut it and install it normally, it's going to hold its pressure. So they'll be good for decades. If you can find a 20-year-old fitting, you can probably go ahead and install it.
How recommend for cleaning incompatible product off of the pipe? Or, what happens if you find that an incompatible product has been sprayed or used or has touched the outside of the pipe?
That's kind of a tough question because it depends on what it is and where it is and how much of it there is. Some things, even if you think you can see that you got it all off the surface, you may not be able to see the residue that's left on there. So things like it's things like cleaning products, you know, what are you going to use to take a cleaning product off of a cleaning product? So those can be very difficult to get off. It's best just to do all those pieces of advice that Lainey gave you about avoiding that happening in the first place. Caulks and fire stops, if you can get it all off, you might be okay, but it can be very hard to get it all off. I've, in doing failure analysis, had to try to peel that stuff off the pipe before, and it doesn't always come off very easily, and you have to get every last bit of it off. So for things like a incompatible fire stop, if you found that something like that had been applied, it's probably going to be easier to just take that little bit of pipe out. And it's only the pipe that's touching it. The chemicals don't crawl down the pipe surface. So for something that's applied in a spot like a fire stop sealant, you don't have to take out any more than what's actually in contact.
Tough question to answer.
Yeah, it is.
So another question we had was, what is a typical time, and this is another question because it varies, typical time frame for a pipe failure from contact with a communications type cable or PVC type cable?
Well, it really depends on how much plasticizer is in the cable. Some of them, like, you can even feel how greasy they are. That's the plasticizer bleeding out of the material. So if it's a really greasy, high in plasticizer type of cable, it might fail within a month or two. In other cases, it might take 2 or 3 years for the failure to become evident if it's got less plasticizer content in it.
A question has come up a lot about heaters, which I'm not familiar with that, but EX cable or oil.
So the corrugated cable itself is not incompatible with CPVC. Metal products in general, even metal piping, copper or galvanized or steel piping is not incompatible in contact with CPVC, and neither is the metal corrugated cable. Although I have seen 1 or 2 situations where the corrugated cable actually wore down the wall thickness of the CPVC as they pulled the cable across it. And I don't think I've ever seen a failure due to any kind of oil being on that cable. Just the mechanical damage from the corrugation wearing the wall thickness away.
Oh, no, I don't want that.
I see your lips moving, but
Can you hear me?
yeah,
No.
that's better.
Okay, great. Is there, so one question was, in the case that a material gets dropped off from the compatibility list after several years from project completion, what should we do and what could cause the material to have been removed from the list? And that's an excellent question. One thing I want to start by saying, and then I'll let Michelle answer, is that for the history of our program, we have never had a product on our program that we have claimed as compatible and then has been removed because we found that it's incompatible. Our competitor cannot make that same claim. But if a product is removed from the compatible list, it is more than likely, or most, I mean, 100% of the time to this point, because that manufacturer has chosen to not participate in our program, aka submit for testing again that following year, because either they don't see the value or they discontinue the product or something like that. It's not because it's now incompatible. If in the future that were to happen, we would make a very big announcement and make sure people were informed that, but to date with Lubrizol, that hasn't happened. Michelle, I don't know if there's anything you have to add to that.
No, I think you covered everything. You're right. Usually when something goes off the program, in fact, in every case to date, it has been just because they just didn't want to be on the program anymore. And if something did go from being compatible to actually incompatible, it would then also show up on the incompatible list, which we've never had to move something from compatible to incompatible on the lists.
Can you talk to compatibility with antifreezes?
So antifreezes, there are, as you're probably all aware, there are new listings for antifreezes based on flammability. And so some of those products are listed on the system compatible program. We have our own BlazeMaster, of course, and there are other antifreezes available. In terms of just general purpose antifreezes, there's basically 3 different kinds of chemicals that might possibly be used. Glycerin is what's recommended for use in BlazeMaster systems if you're not going to use one of the new listed products. A general purpose antifreeze should be glycerin based. Propylene glycol is used in steel systems, but it's not recommended for use in CPVC systems. I don't think anybody is using ethylene glycol in fire sprinkler systems, though. That's the third type of general purpose antifreeze.
And I will say that any listed antifreeze, so the 4 products that are on the market that are listed or UL listed, UL's antifreeze testing protocol includes compatibility testing with CPVC. So if it's a listed antifreeze, it is compatible with BlazeMaster CPVC and Spears CPVC. It doesn't matter the brand. It is tested to ensure compatibility with CPVC. But all the antifreezes are part of our FBC system compatible program too, just as an added measure. Are there any known products that release incompatible vapor over time, like off-gassing, or is direct contact the only concern?
Well, if the vapor can settle like kitchen grease can, so when you cook fried chicken in your kitchen, for instance, you're vaporizing the grease and it floats up and then comes down and lands on your cabinets. So if it can condense and land on the piping, then it will be in direct contact. If it's just a gas, like say chlorine vapors in a spa area in a hotel, for instance, that's not a problem. Or even if you have to fire sprinkler somebody's chicken farm and you've got, you know, chicken smell and those kinds of things. Yeah, that's not a problem either. As long as it stays a gas, it's not a problem. But if it can condense and land on the pipe, then that might be an issue if it's something like kitchen grease, for instance.
And not to put you on the spot, it's okay if you don't remember how to answer this right now, but General Air came out with a new corrosion, a vapor corrosion inhibitor. Um, and I know we couldn't add it to our program, but would you mind reminding or, you know, just sort of explaining what we found and how it's okay to use with DPVC or with
Yeah,
BlazeMaster?
and basically the reason we couldn't particularly add it, I think, is we couldn't think of a way to test gas, but we don't really need to test gas. Um, the chemically driven cracks are basically caused by the liquid forcing its way into the plastic, and gas just can't exert enough force. I mean, it could theoretically be kind of absorbed by the CPVC, but it's not going to be able to disentangle the molecules from each other, basically. So yeah, as long as it's a gas and not a liquid on the surface, it can be used. And so that General Air corrosion inhibitor is also not a problem for CPVC.
What about the foam that's used to stick the insulation boxes together around the CPVC pipe? But the foam sometimes sticks to the pipe as well. Would that affect the pipe? And if so, do you recommend it be cleaned?
I am not even sure I understand that question. Do you understand it?
I know Roham direct messaged me a couple of times about it, so
I would need
Roham,
a picture or something. I can't even visualize.
if you want to email blazemaster@lubrizol.com with maybe a picture or better description, we can definitely get. Dove dish soap. Does that fall under the surfactant category? Apparently, a lot of bidders use that as a leak detector.
Yeah, dish soap is definitely a surfactant. Anything that kind of looks like soap and acts like soap is probably a soap. And so that's certainly the case with dish detergents as well. I don't know if that particular one contains a compatible or incompatible um, surfactant in it. So I can't tell you specifically, but um, it falls into that category. So it is something you should question at least before just going ahead and using it.
What about polyisocyanate foams?
So that's a polyurethane foam. Isocyanate is, I can't remember whether it's part A or part B, but that goes into polyurethane foam.
And what have you seen to be used as barriers between a non-compatible item and BlazeMaster CPVC? I know that Deco Shield, for example, you know, has been used, but I know that can get kind of pricey, but I've seen people use the bags that CPVC comes in themselves. I've seen them use cardboard boxes. I'm not that I'm recommending any of those, but that certainly has been used. I don't know, Michelle, if you have any other
I've seen them use the pool noodle insulation too, as well. So as you can use that tube insulation, I suppose, but again, you want to choose a compatible one. So it needs to feel crispy like a pool noodle if you're going to use something like that.
So what about in like air aspirating systems like Vestas systems where there's not pressurized pipe? Would electrical tape on that be a problem?
Yeah, so the plasticizer is still going to leach into the CPVC, even if it's just a Vestas. So that's one of those drawing air to sample for smoke, right? So it is still going to leach into the CPVC. You don't have the force of the pressure inside the pipe working on the CPVC, and even if you crack through it, you're not gonna leak water onto the floor, but you might lose some of your vacuum because that tape can still crack through the pipe or the fitting. And if for whatever reason you're putting electrical tape on there, you could switch to something compatible, or that would be preferred, but don't put it on the fittings because, again, the fittings have more stress than the pipe. So, but preferably, I listed 5 other kinds of tape that could be used. You can also use nylon zip ties if you need to. I assume they're using it to affix something to the system or something. If you need to affix something to the CPVC, nylon zip ties are fine too.
Can you speak to just how you recommend pipe and fittings be stored? You explained that UV light doesn't affect its performance, but it makes it unbrittle. But that doesn't mean that we just want you to leave it out in the sun, right? Can you just speak to some of our guidance on how you really store CPVC?
Preferably just covered with something opaque, so a typical tarp or in a cardboard box or something like that, for outdoor storage, and preferably also protected from damage, of course.
Did you see any that we didn't get to, Michelle, that you wanted to answer? Is any duct tape? How about duct tape in general?
Duct tape is compatible with CPVC. There are none on the program. I think I saw that on the system compatible on the question. There are none on the program because, again, duct tape is such a large category general purpose product. They don't care about participating in our program, but you can use duct tape on CPVC. It will be just fine. I see one about Loctite 577. I believe that's an anaerobic thread sealant. There is only one anaerobic thread sealant on the system compatible program, and you should use that one if you need a compatible anaerobic thread sealant. Almost every other anaerobic thread sealant is incompatible.
Would air fresheners be considered a fragrant?
Would air pressure be considered what?
Sorry, air fresheners, do those fall under the fragrance category?
If you put a fragrance inside in order to do an air test. So I've heard of people putting, like cologne in there or peppermint oil or something like that inside the system to do an air test. And I've looked at failures caused by this. That's the problem. It's not the air itself. Although some of the manufacturers don't recommend air testing the systems for other reasons. But if you're going to go ahead and do it, don't put a fragrance in it. That's a bad idea.
What about any type of PPE that has a coating in, like gloves, for example?
So like I've seen rubber gloves that have a powder coating in them, and that's usually talcum powder, and that should be fine. Not aware of any other kind of coatings, but rubber gloves are fine. You can handle the pipe with that. Those don't have incompatible plasticizers in them. And if they have a powder coating inside the glove, that's talcum powder. It's going to be fine too.
One last question. If a system has an unknown or unlisted antifreeze, how long would it take to cause failure? If replaced soon enough, would this resolve it? So I think the second part of that question is very easy to answer. The first one is much harder.
So it depends on what the incompatible antifreeze is. Even though propylene glycol is not recommended for use in CPVC, I've never really seen failures associated with it. There is another, I didn't mention earlier, we talked about glycerin, propylene glycol, and ethylene glycol. There is also something called polypropylene glycol, which is not the same as propylene glycol. And that is very incompatible with CPVC. should not be used. You'll probably see failures within a couple of months, and you can't really clean it out. So don't make that mistake. Don't put polypropylene glycol in CPVC.
I think that's all the time we have for today. Thank you so very much for joining us. And if we don't talk before the holidays, we hope everyone has a wonderful holiday season. Thank you, guys.
Bye, everybody.